Our next category of reaction is called a single replacement reaction, sometimes also called a single displacement reaction. In this reaction, we're going to take elemental aluminum and react it with a solution of copper chloride. When these two are reacted, the metals that are reacting, in this case, switch places. In this case, we have elemental aluminum as one metal, and another metal that is forming a compound with chlorine, copper chloride. The copper in the copper chloride switches places with the aluminum metal. This forms aluminum chloride, a new solution, and it frees up copper to be an element. We can see this happen as I speed up the reaction. The copper starts to become more clear as it forms because we can see its characteristic color. As the reaction progresses, the aluminum starts to get consumed and it starts to disappear. The reaction continues and more copper forms and it starts to fall to the bottom of the beaker. As the reaction progresses, it starts to slow a little bit as the copper starts to coat the bottom of the aluminum ball. So I'll need to get a glass stir rod here eventually and start to whack it a little bit. This will help speed up the reaction further. We can see much more clearly now that the copper is definitely falling to the bottom of the beaker as it forms, and the aluminum gets consumed and forms the new solution of aluminum chloride. This is evidenced by the changing color of the solution as the copper chloride, which is a blue color, starts to disappear. One thing you'll notice also is bubbles are forming. That's actually part of another side reaction that's happening with aluminum and other things that are present in the beaker, and not part of this reaction at all. And sometimes that happens in chemistry. This reaction won't actually go to completion here because it will take over a day. So let's go ahead and take a look at what a single replacement looks like at a very basic level. So we can say a single replacement reaction or displacement reaction occurs when we have a substance, AB, a compound AB, and another substance, just C. And C will always swap places with another substance within AB, either A or B. And so one way we can express this is as AC plus B. There are many ways to express the single replacement reaction, but as long as substance C is swapping places with either A or B. And that's going to free up one of the substances within the initial compound that wasn't initially free. In our case here, we have A, a metal, and B, a nonmetal, and B is going to swap places with C, another nonmetal, therefore freeing up B to be on its own, and C will no longer be on its own, it will be bonded to the metal A. This is frequently a situation that happens where A is the metal, but it's not always the case. As long as it follows the general concept where we have one substance swapping places with another, it can be called a single replacement reaction, as seen in the motion diagram below. This will always be the case with single replacement reactions. It just has to follow the general idea that one substance is swapping the place of another within a compound. Let's take a look at what this looks like overall, showing the overall particle diagram along with the basic reaction. Now let's take a look at what a single replacement reaction looks like on a molecular level for the reaction we actually did in our demonstration, where aluminum metal is reacting with a copper chloride solution. In our reaction of aluminum with copper chloride, we can see that we have two starting substances, aluminum as an element and copper chloride as a compound. While stoichiometrically we have two aluminums and three copper chlorides, it still follows the single replacement mechanism. As we'll see in our particle diagram, what will happen in this case is that our two metals, aluminum and copper, will do the swapping. leaving chlorine to be the substance that is partnered with. As the reaction progresses, aluminum swaps places with copper and bonds to chlorine. The stoichiometric proportions have to change in order for the reaction to work, but the single replacement mechanism still remains as we would expect. Copper is then free, as we would expect with a single replacement reaction. We form 3 coppers and 2 aluminum chlorides. And finally, here is our overview of the single replacement reaction for aluminum reacting with copper chloride. So we can get the big picture to make sure we understand how single replacement reactions work.